This video is going to talk about terminating and repeating decimals. And there are three main terms that you're going to need to know in order to get through this section. The first is a rational number. And a rational number is any number that can be written as a fraction. It's most of the numbers that we've been working with this year. So, for example, 5/7, 3/8, 14 seconds, even 3. Even whole numbers are rational numbers because whole numbers can be written as fractions. You just put them over 1. So long as the numerator isn't 0, you're good to go. And when the numerator is 0, you break math anyway, so don't do that. So that's a rational number. Any number that can be written as a fraction. Or as a fraction. Now, when you take those fractions and you make the Ellen divide, you're going to get one of two different numbers. And the first number is a repeating decimal. And this is the decimal form of a rational number. It actually encompasses all the numbers you're going to get. Everything that you're going to get is a repeating decimal. So let's take a look at 1/9 and let's make that into a decimal form. So the first thing I'm going to do is I'm going to make the Ellen divide. I'm going to ignore the negative sign right now, and I'm going to slap it back on at the end. And if you don't put it back on at the end, you're going to get it wrong. You have to re-record the video like I have to do right now. So, what you're going to do, because 1 is on the inside of the L, it goes on the inside of the division sign. 9 goes on the outside. 9 goes into 1. Well, 9 doesn't go into 1. So we have to put the decimal and put a 0. 9 goes into 10 one time. 1 times 9 is 10. 1 times 9 is 9. 10 minus 9 is 1. Bring down the invisible 0. 9 goes into 10 one time. 1 times 9 is 9. Makes a 1. And then we could just keep going on and on and on with this. I'm going to flip this decimal up here. So negative 1/9 is actually going to be negative 0.111111, and it'll just keep going. But we don't want to have to keep writing this over and over and over again because you'll never finish with the video. I'll never finish recording the video. So instead, what I'm going to do, I'm going to write negative 0.1 with a bar notation on top. And that bar notation on top is going to tell us that 1 is going to repeat over and over and over and over again. So that is a repeating decimal. There are times when it will look like there is nothing repeating when you finish. So let's take a look at negative 3/4. When I take negative 3/4, I'm going to make the Ellen divide. 3 goes on the inside. 4 goes on the outside. 4 goes into 3. Well, it can't, so we need a 0 there. 4 goes into 30. How many times does 4 go into 30? Let's think about this. 4 goes into 30 7 times. 7 times 4 is 28. 30 minus 28 is 2. We need to bring down an invisible 0. 4 goes into 20 5 times. And we get 0.75. And there doesn't look like there's anything repeating. Negative 0.75 is going to be our answer. There doesn't look like there's anything repeating in there. We're going to talk about that in a minute, but first we're going to focus on repeating decimals. 0.3 repeating is going to be 0.3333333, and it will keep going because the bar notation is above the 3. So that tells us that the 3 repeats. 0.76, when that bar notation is above the 7 and the 6, will be 0.7676766, and just keep going. Here's where people start to get a little bit confused. 0.491. If we take a look at 0.491, and the first thing we're going to do is write out the original number, what is the bar notation on top of? The bar notation is only above the 91. It's not above the 4. So that 4 is not going to come up again. It's just going to be 0.491919191, and that'll go on. Same thing for 0.375. That will be 0.375. The only thing repeating is going to be that 5. So we're going to keep going and going and going and going. But the 3, 7, because they're not under the bar, they don't repeat. Terminating decimals are still the decimal form of rational numbers, but they're a special subset. Because terminating decimals have a repeating digit of 0. So we go back, we look over here, and it doesn't look like anything's repeating on 0.75. But we still have all those invisible zeros that come after it. Just like 3 had invisible zeros. So a terminating decimal is a decimal that we see stop because we don't have to keep writing that 0 over and over and over again. So 0.9 can actually look like 0.900000000, but we don't write all of those zeros because it doesn't make sense to. So instead, we shorten it to just 0.9 to write the important parts. Same thing for 0.78. Technically, it has all of these zeros after it, but we shorten it. 0.024. And we shorten that. We don't get rid of this 0 because it's important. It's between a decimal and a number. Same thing for 0.16. And on and on and on. So what you're going to do on your form is you're going to do 3 things. You're going to write -3/5 as a decimal. You're going to write -2/11 as a decimal. My biggest concern isn't necessarily what the answer is, but if they are terminating or repeating and how you know. Then you're going to take these 2 decimals, 0.327 with the bar notation above 27 and 0.6, and you are going to write them out to the 10th decimal place, which is technically the 10 billion spot.